welcome to my channel. Today I have brought up a special topic for you that says, is angular velocity a scalar or a vector quantity? So today we're going to discuss that is angular velocity a scalar quantity or a vector quantity. So what do you think about it? Let us see how correctly you think or how correctly you thought. So surprisingly, angular velocity is both scalar as well as vector under some circumstances. I am also surprised to know that that angular velocity is sometimes a scalar as well as vector under every circumstances which we are undergone with. So let us see which are the circumstances in which uh, angular velocity is a scalar quantity and the circumstances in which angular velocities are vector quantities, and if they are sometimes scalar sometimes vector, therefore it clears that it is not truly scalar or truly vector. So it is clear that angular velocity is not truly scalar or a truly vector quantity. So let's see it how. For finite rotation, angular velocity is scalar quantity. And let me discuss with you that what are the circumstances under which a quantity is a vector quantity and a quantity is a scalar quantity. So for vector quantity, it should have magnitude plus direction and follow the triangular law of addition or the vector law of addition. So vector law of addition. These three criteria should be followed in order to be said that a physical quantity is a vector quantity. So for finite rotation, as you can see a circular path, it's a finite rotation, means we can finite it, we can see clearly that it is a rotation happening. So for finite rotation, it is a scalar quantity. Why? We can see that it have magnitude, it have directions, but the criteria under which it doesn't suit is this, that it doesn't follow the vector law of addition. Therefore, for finite rotations like one complete circle, it is a scalar quantity, or half complete circle, or 1/4 complete circle, or 1/3 of a circle, it's a scalar quantity. Why? Because it don't follow the vector law of addition. Now let's come about the condition in which the angular velocity is a vector quantity. So on the same hand, for infinitesimal rotation it becomes a vector quantity. So for an infinitesimal rotation it becomes a vector quantity. Let us see it how. See, this is an infinitesimal rotation, this much very small, therefore it is infinite, sorry, let me erase it, infinitesimal rotation, it's a vector quantity. Let us see it how. See, this much is there, so one vector there, one vector above, and the third vector above. So this one vector here, and last vector here. So see the direction, it goes like this, and the direction of the velocity is like this for some instances, like this for some instances. Therefore it becomes a vector quantity under infinitesimal rotation. Clear to you? So we conclude that as it follows vector law of addition, therefore it's vector quantity under this situation. So we conclude that when finite rotation takes place then it's a scalar quantity. And when infinitesimal rotation takes place, then it becomes a vector quantity. So we conclude that angular velocity can be sometimes scalar and sometimes vector under given situation. Thank you.